Well, hello, class. It is time for our next section, which is going to be on trigonometric ratios. Trigonometric ratios. Have you ever heard of sine, cosine, tangent? Well, at last, it's your chance to learn this amazing stuff. Actually, this material is extremely practical, very useful. In fact, I would say trigonometric ratios are one of the best things you can learn in algebra. So let's get at it and see how it goes. So best of luck as we take this on and study hard, watch this video, and especially the first screen that I'm going to show you is extremely important. So pay attention and hopefully this will go very well for you. Okay, here's our first screen. You see here we have sine theta, cosine theta, tangent theta over on the left. Now sine of theta. Theta is that Greek letter. You see the little circle with a line through it? That is called theta. 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 It's a Greek letter, and it just represents an angle. So just be aware that theta represents an angle. So this guy here, where should I write this? Over here. This symbol is called theta. Theta. If I spelled it right, I think I spelled it right. Theta. So my goodness, that looks large. So the Greek letter theta just represents an angle. So theta could be up here, okay, or it could be down here where B is. Theta just is a name for an angle. So get used to hearing it and all will be well. Okay, theta. So sine of theta, cosine theta and tangent theta are the fundamental, in fact, sine and cosine really are the fundamental trigonometric ratios right there, sine and cosine. And I could give you a detailed explanation based on the unit circle, a circle with radius 1 and coordinates along that circle, but the truth is we will leave that till you get to Algebra 2, so you can learn about the unit circle and all of that stuff. But for now, let's just think of theta, sine of theta, and cosine theta and tangent theta as being ratios of sides of a triangle. So I want you to notice here that sine of theta is defined to be opposite over hypotenuse. Now, what do we mean by opposite? Well, let's say that theta is angle A up there where the big A is, and I've marked it in the diagram. Okay, you see there I've got theta right here. So if this is the angle that we're talking about right here, where is the opposite side? The opposite side, if you imagine that you're standing at this angle and you're looking across this triangle, the opposite side is right here. That's your opposite side. Little a is opposite big A. And you notice that I've written it right here. Little a opposite big A. Little b opposite big B. So that's what we mean by opposite. Okay? Opposite is the angle directly across, or sorry, the side directly across from the angle that's under consideration. So if we're talking about sine of theta, and we're talking about the red angle that I've shown here, it's equal to little a over c, okay? Little a over c. Because hypotenuse is always the hypotenuse. When you're dealing with a right triangle, the hypotenuse never changes sides. It's always opposite the 90, okay? And it's always the longest side. Remember from where we were doing Pythagorean theorem, the hypotenuse is always the longest side and it's always opposite the 90, okay? So the other sides are called adjacent and opposite, opposite and adjacent. And which one is opposite and which one is adjacent depends on the angle that you're talking about. So right now we have circled, I've circled here in yellow, and now I can circle it in green, this guy right here. If we're talking about this angle, the opposite side is A and the hypotenuse is C. Or if we were talking about cosine, the adjacent side would be B. This would be adjacent, and hypotenuse is still the hypotenuse. So please take note that the opposite is directly across and the adjacent is the other side. Now, one other way to think about this, the adjacent side of a triangle, when you're talking about a particular angle, the adjacent side is always one of the sides of the angle. Notice that, and the hypotenuse will be another side. So notice the adjacent side is one side of your angle. It forms one side of your angle. The opposite side is never a side of your angle, okay? So hypotenuse and adjacent are the sides of your angle, and the opposite is directly across. So I've kind of beat that to death. I hope you've understood. All right, so when we're talking about tangent, tangent is opposite over adjacent, opposite over adjacent. So again, if we're talking about this red angle that I've marked here as theta, then opposite over adjacent would be A over B, okay? A over B. So let's go through this. Let's talk about this now one last time. Here's theta, my red angle that we've indicated right here, this one, okay? This guy right here, if this is the angle under consideration, sine will be what over what? It'll be A over C, opposite over hypotenuse, opposite over hypotenuse. Cosine will be adjacent over hypotenuse. That will be B over C, B over C, if we're talking about cosine. Adjacent over hypotenuse, okay? Adjacent over hypotenuse, okay, if we're dealing with cosine. And what if we're dealing with tangent? Tangent will be opposite over adjacent. Opposite over adjacent. That would be tangent. Okay? So that's cool, right? Not too hard. Let's back up a little bit and let's talk about a different angle. Okay? What if instead of angle A up there being theta, what if I erase that guy and I said, let's let this angle down here be theta? Okay, what if this angle down here is theta? Angle B, what if that's our angle theta? Then what is opposite now? Opposite will be, just like I told you, straight across, okay? Notice it's no longer A. Opposite is now B. You got that? Stand at angle B, where theta is, the angle of consideration, and look directly across the triangle. What is out there in front of you is B. Hypotenuse is still the hypotenuse. The remaining side, the other side of your angle, is the adjacent side. So let's go through this now. How about sine of theta? What is sine of theta now? Sine of theta would be opposite, that's B, okay, opposite B divided by hypotenuse. That would be sine of theta, B over C, okay, B over C. How about cosine of theta? Cosine would be adjacent over hypotenuse. Remember, adjacent is one of the sides of your angle. So that would be, this is a side of your angle right here. Adjacent is A. And hypotenuse is always the hypotenuse. It's the longest side that's opposite the 90. A over C would be equal to cosine, okay, A over C. What if we were now going to be talking about tangent? Tangent is opposite over adjacent. That is B, that's your opposite side, over the adjacent side, A, B over A. Okay, so now I think that is a pretty thorough explanation of how to determine your ratios. The thing now that I want to talk about that, well, we're going to give you some examples, but the thing I want to give you last here, down at the bottom of the page here, is SOHCAHTOA. SOHCAHTOA. Suck it to 'em, yeah? SOHCAHTOA. S-O-H-C-A-H-T-O-A. SOHCAHTOA. Sine, follow along here. Sine is opposite over hypotenuse. Okay? Cosine. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So this is a little saying, a mnemonic if you like, that helps us to remember the ratios. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And lastly, tangent, opposite over adjacent. SOHCAHTOA, SOHCAHTOA. There you go. I hope that sticks in your mind. SOHCAHTOA. Just remember how to spell so, S-O-H, not S-A-H. SOHCAHTOA. Very good. All right. Now we're going to move on and we're going to try to do some examples for you. Hopefully this will be not too hard. I hope it works out well for you. So let's advance now. And my screen is locked. What is going on? Here we go again. Here we go. All right. So I'm going to roll this up. I'll keep that at the top there. So hopefully it will help us to remember what the various ratios are. So our first example, we would like to find the three trigonometric ratios for angle A. Okay, angle A is going to be our theta angle up here. This guy right here is going to be our theta that we're thinking about. So angle A, you may be confused. Why am I labeling things angle A and then mentioning theta? In science, we almost always use theta, alpha, beta. We use Greek letters to represent angles. In geometry, they label things according to letters. So angle A is the angle that we're thinking about here. So what is sine of angle A? Here we go. Sine of angle A is the way they would write that. Sometimes they don't put the angle thing. They'll just say sine of A. What is sine of A? Look up here at the top of the screen. SOHCAHTOA. Sine equals what? Answer me. Sine equals opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse, right here. That's sine. Sine opposite over hypotenuse. Which is the opposite side for angle A? The opposite side is right here, 24, okay? That's our opposite side. The other side of the angle is the adjacent side, and that would be 7. And of course, the hypotenuse is the hypotenuse. Identify the hypotenuse for me. That would be 25, wouldn't it be? So this is... Hey, the screen doesn't want to write. Just give me a moment here and get through this. I really wish I had a graphics tablet. I know sometimes it's frustrating to you because things get slow because they're so sloppy and it just doesn't work right. This is the hypotenuse, okay? I'm going to abbreviate now. Adjacent will be ADJ, opposite OPP, and hypotenuse HYP. So sine equals opposite over hypotenuse. That would be opposite side, 24, over hypotenuse, 25. Sine will be 24 divided by 25. Sine of angle A. Remember, we're talking about angle A, not some other angle. What is cosine of A? Cosine of A is going to be equal to adjacent over hypotenuse, 7 divided by 25. And tangent of angle A is going to be equal to opposite over adjacent. That's going to be 24 over 7. There you have it, the three trigonometric ratios. Now, usually in science, you will not be using ratios like that. They will be decimal numbers. So you would work these out. What's the sine of angle A? It would be 24 divided by 25, which is just slightly less than 1. Slightly less than 1, okay? And what's cosine? 7 over 25, which is roughly a little less than a quarter, okay? A little less than 0.25. So you can see here how these ratios could be converted to decimals. We're not going to be worried about that right now, but here you have your three trigonometric ratios for angle A, sine A, cosine A, and tangent A. All right, let's move ahead to another example. Okay, our second example, we are going to evaluate sine of 37 degrees. Now, one thing that I have not yet explained, sine and cosine are simply numbers. They are ratios of two numbers. They are dimensionless. So if you take the ratio of sides, it doesn't matter if the sides are in meters or in feet or in inches or in millimeters. If you take the ratio of two sides, so long as they're measured in the same units, okay, those ratios are dimensionless. They're just numbers. Okay, so sine of 37 is just a number. How do you find out what sine of 37 degrees is? So what we're saying is if we have an angle of a triangle, a right triangle, and it is 37 degrees, what is the sine of 37 degrees? So we need a calculator to do this. In the olden days, we used tables, mathematical tables, but these days we have nice calculators that'll do this for us. So you have to have a calculator or a table. Nobody memorizes all the trigonometric functions for every angle. So you have to have a calculator. So here we go. Let's look at this little calculator right here. We want sine of 37 degrees. This is the Desmos scientific calculator. I don't know if you can see it up here, but we've got desmos.com/scientific. Desmos.com/scientific. So So desmos.com/scientific. So here we go. This is a web page that we're on. I'm not sure if I'm recording the entire screen. I'm not sure if you can see the bar up at the top, but in case you can't, desmos.com/scientific. So here we go. Let's find our function. Our function is going to be sine. So you go here to where it says function. See my mouse? Click on function, and then you type sine. And now we need 37 degrees. So we go back to main, where we get our numbers, okay? And we type in 37, okay? Notice what sine of 37 is. It's right over here on the right. Do you see it? It's 0.6018. 0.6018. So that's our sine. 0.6, looks terrible, 6018. Usually we give our trigonometric ratios to 4 decimal places. That's all the way out to the 10,000th of a unit. So 0.6018. Sine of 37, 0.6018. Now, in right triangle trigonometry, sine and cosine vary between 0 and 1. But if you're dealing with the unit circle, sine and cosine are actually graphs. And have you ever heard of a sine wave? You may have heard of a sine wave. Sine wave would look something like this. Okay. And cosine is kind of the opposite. It starts at 1 and then comes down. So it's out of phase by whatever that is. Anyway, cosine, let me think here. It starts like this. Something like that. So cosine and sine are not together. They're different. But anyway, they go between up here. My graph is not drawn very well. This red line is up just a little bit, or the blue line is down just a little bit. This is +1 up here, and this is -1 down here. So this is -1, and this is +1. So it varies between plus and -1. Remember, short, repetitive exposures. I just showed you something that I'm not going to test you on, but when it comes up again, hopefully you will remember it a little easier, okay? Sine and cosine vary between plus and -1, and they have a period of 2 pi or 360 degrees. So out here, they start repeating again. So the whole thing starts over again out here, see? So the blue one, I shouldn't have done that in red. The blue one starts down and the red one starts back up again. So things start repeating here at 360 degrees. This is 360. Okay. Whoa, I am having a hard time with this screen. Doesn't want to write. 360, or very frequently we use in more advanced math. It's not to say we don't use right triangle trigonometry, we do, but this is often referred to as two pi radians, okay? So sine and cosine vary between plus and minus 1. But if you only are dealing with the first quadrant, okay, the first quadrant, up to 90 degrees, and this is 90 right here. This is 180 out here. This is 180. This is 270, and this is 360. So if you only come to 90 degrees, notice sine went from 0 up to 1, and cosine went from 1 down to 0, okay? So that's sine and cosine. They vary between 0 and 1 if you're only dealing with 0 to 90 degrees, which is what we are doing when we're dealing with right triangles, okay? When you're dealing with more advanced math, then you can talk about the unit circle and revolutions around the unit circle, lots of degrees besides 0 to 90, okay? You can have negative degrees, etc. Okay, so for us, though, for now, we're talking about right triangles, 0 to 90, between 0 and 1, okay? Sine and cosine vary between 0 and 1. So here we have sine of 37 equals 0.6018, 0.6018. Now, we can actually work backwards. If we knew this number right here, if we knew this one, we could tell you what the angle was, okay? We could tell you what the angle was. 0.6018, we could go backwards and get the angle. That is something we call inverse sine. It's coming in another example. So again, short repetitive exposures. You don't really have to worry about all this stuff right here. I'm just showing you something that I hope someday will make your life easier when you see it again, because you will see it again. All right, let's move on to example number 3. Example number 3. Let's scroll on up here, get ready to go with example number 3. So example 3, we would like to find the tangent of 14 degrees. Tangent of 14 degrees. Again, you will need a calculator, so let's jump back to our Desmos Scientific Calculator, desmos.com/scientific, and let's calculate this. So first of all, we clear our screen, and now we want a function. The function is going to be tangent. Our angle is going to be 14. So I put in 1, 4, and you can see it's right over here on the right, 0.2493, 0.2493. Very simple. Please, when you're writing these things, don't forget to put a 0 in front. 0.2413. 3, sorry. Well, 2413. That's our tangent. 2493, excuse me, 2493. 2493. Okay, tangent 14, 0.2493. The leading 0 is important to make sure that people see the decimal point. Okay, that's example number 3. Let's move on and find another one, example number 4. So example number 4, we would like to solve this right triangle. Okay, solve the right triangle. What do we mean by solve the triangle? when you hear the expression solve the triangle, what we need is all the angles and all the sides. All the angles and all the sides. That's what we're looking for. So to begin with, let us think about how we're going to label the sides. First of all, we have this side right here, this one, okay? This side is XY. This side over here is YZ, and this side here is XZ. Usually we would list them in alphabetical order, okay? So we would write this one as XZ like that. XZ equals, okay? That's how we would indicate our sides. This one over here we would list it as XY. Okay, this one up here we'd list as YZ when we're trying to identify the lengths of the sides. So let me clean my diagram up. Okay, so to begin with, we need to decide how to proceed. Well, think about your trigonometric ratios. If we're talking about angle Z up here, 39 degrees, what side is 7? What side is 7? Where is it opposite? Opposite the 90. So what is this side 7 called? This would be our hypotenuse, wouldn't it? It would be the hypotenuse. So do you know something that involves hypotenuse? Yeah, you know two things. You know cosine and you know sine. Let's start with sine. So sine of 39 equals opposite over hypotenuse. Opposite would be like little z over here. Little z over, in fact, I probably shouldn't use that notation because it's going to confuse. The opposite side is xy. Now, it's easy to get confused because xy, we mean segment xy. We mean the segment xy. It's not x times y. We're naming the side of a triangle. So sine of 39 is opposite, which is segment xy, over hypotenuse, over 7. Opposite over hypotenuse, which is xy over 7. How do you solve this thing for the segment xy? You just multiply both sides by 7, okay? So xy, our little segment xy, I really don't like the notation here. Let's do it anyway. All right, we multiply both sides by 7. When I multiply the right side by 7, the 7's cancel, and I'm left with xy. And then I take 7 times sine of 39. So we do it like this, 7 times sine of 39 degrees. Sine of 39 times 7. That's how we get xy. So what does it come up to be? Okay, we have to go to our calculator and we work this out. So it's pretty direct. Here's our calculator. We clear things out. Okay, clear it all. And now we need 7, okay, times the sine of 39 degrees. And what do we get? 4.405. 4.405. And how many decimal places did they ask for? Let me check. To the nearest tenth. So this would be 4.4. They said to the nearest tenth, so we would list it as 4.4. Back to our diagram, we would say 4.4 to the nearest tenth. 4.4, okay? That is segment XY. Okay, now we need, obviously, the other side, which is YZ. How do we get YZ? Well, YZ we can do with cosine. Cosine of 39 is equal to YZ over here. Divided by 7. So it's adjacent over hypotenuse. Multiply both sides by 7. And when we do that, what happens? Cancel. And we're left with this guy right here. So we get YZ. And I should stick with my same colors, I suppose. YZ is equal to 7 times the cosine of 39 degrees. And what does that come up to be? Back to our calculator. Okay, clear things out again. And now we're going to go 7 times what? Times the cosine of 39. We get 5.44, or to the nearest tenth, 5.4. 5.4 to the nearest tenth. Okay, so we've got our sides now, 4.4, 5.4. So this one was 4.4. This one was 5.4. We only have one thing left to solve for, and that's this angle right down here, angle X. Okay, this guy right down here we haven't found yet. So how do you get angle X? Well, there's two ways you can do it. You can do it by subtraction, because you know that the three angles of the triangle add up to 180. And since this angle right here is already 90, you know it's 90. What's 180 minus 90? It's 90, isn't it? So 39 plus this angle must be equal to 90. So 90 minus 39 is our angle. Well, 39 is almost 40. So this is going to be 51, isn't it? 51 degrees. So we can just write it in, 51 by subtraction. So angle X, and this is how we can label it. I guess I'll do it over here. Angle X is equal to 90 minus 39, which is equal to 51 degrees, okay? Sometimes if you want to be really picky, they do like this. What they mean by that is the measure of angle X. The measure of angle X equals 51, okay? All right, so that is example number 4. Let's do now another one, example number 5. Okay, so now example number 5, we need to solve this triangle. Solve it, which means find all sides and all angles. Now, could you find side B, the little b there, opposite angle B? Could you find that? I think you could. What method might you use? Do you remember Pythagorean theorem? It would work. You could use Pythagorean theorem. But since we are studying trigonometry, right now we're doing trigonometric ratios, we're not going to use the Pythagorean theorem. Instead, we're going to use our trigonometric ratios. So if you look at any one of these angles here, other than angle A, because we usually don't talk about angle A for sine, cosine, or tangent, we're using angle B and angle C, okay? So if you look at angle B, what is 6 and 15 in relationship to angle B? We're talking about this guy right here. Talking about this guy right here. Then 6 and 15 would be what? What would you call them? Well, 15 is what side? What would you call 15? Would you not call it the hypotenuse? It's opposite the 90, remember? It's opposite the 90. So what is 6 relative to angle B? It would be the adjacent side. It's not the opposite side. The opposite is B over here, little b. So 6 is the adjacent. So what trigonometric function involves adjacent and hypotenuse? Ah, you're right, cosine. Cosine of angle B. So cosine of B, angle B, if you like, is equal to adjacent 6 over 15. 6 over 15. So now remember, we're solving the triangle, which means we need to know the measure of angle B. Here's where it gets a little more exciting and very cool. We need to find angle B. It's 6 over 15. So how do you find it? You do something known as the inverse cosine. So watch this. The inverse cosine of 6 over 15 will be equal to angle B. Because if you know the cosine is 6 over 15, then you can go backwards to get the angle, okay? And let's make sure we're clear. It's 6 over 15 that we're doing the inverse cosine on. That will be angle B. So it's the inverse cosine of that ratio. Let's go over to our calculator and work this out. Here we are. Clear it out again. And if you do 6 divided by 15, what do you get? 6 divided by 15 is 0.4. That's nice. Comes out nice and clean for us. 6 over 15 is 2 over 5, which is 0.4. So we're going to be doing the inverse cosine, if you like, on 0.4. So let's go back over here again to our little guy right here. So this is the inverse cosine of 0.4. Okay, inverse cosine of 0.4 is going to be equal to our angle. So back again to our calculator, and we'll clear it, and let's do this now. So it's very simple. You just take your function, okay? You do inverse cosine, see the inverse cosine, and you put a 0.4 in there. So you go back to your main, and then type in 0.4. You could do this, by the way, on a handheld calculator. You don't need the Desmos Scientific here, but I'm trying to show you, so that's why I'm doing it this way. Okay, and it equals to 66.42, 66.42, and if we do it to the nearest tenth of a degree, it'd be 66.4, 66.4. 66.4 degrees. So let's label that right there. $66.4. So what's angle C down here? What's angle C? Well, angle C, or if you like, the measure of angle C will be equal to 90 minus 66.4. 90 minus 66.4, which is going to be what? It's going to be like 23.6 or something like that, if I'm right. Okay. Yeah, 23.6 degrees. That would be angle C. Now we're remaining with one thing, side B. How are we going to get side B? Well, we need a trigonometric ratio that involves side B. We need something that involves side B. How about sine? Sine of yeah, let's do sine. Sine, by the way, there's different ways you could go. We could use the 23.6 that we just calculated, or we can use the 66.4. And now that I think about it, I wish I had kept another decimal place because we're going to get some round off here if we don't watch out. Let's go back to inverse cosine. It was 66.4 what? It's 66.422. 66.422. So 0.4 422. That way we won't get so much round off here, okay? So now if we're going to use this angle right here for our calculation, we're going to be using this one for our calculation, and we want it to include side B, because side B needs to be known. We need to find it. Then which trig function would you like to use? Well, what side is this relative to 66.4? Angle B up there, 66.4. This little b is the opposite side. See, it's the opposite side. And you can use tangent, because we use opposite over adjacent, or we could use sine, opposite over hypotenuse. I'm going to use sine. So sine of 66.422, oops, sine of 66.422 is going to be equal to opposite, little b, over hypotenuse, which was 15. How do you solve this one? Well, folks, this is just algebra. If you want to solve for b, this is like a simple little ratio. You multiply both sides by what to get rid of that 15 in the denominator? You multiply both sides by 15. So we go 15 here, okay, and we go 15 over here, okay? By the way, when you have a coefficient in front of a trig function like this, 15, that's always 15 times the sine of 66.42. And so, of course, over here, they cancel out, and we are left with b, little b, okay, little b is equal to 15 times the sine of 66.422. And what does that work out to be? Well, let's go find out. Back to our scientific calculator, and we will calculate it. Okay, clear out things. And we do 15, and we're going to multiply by a trig function, sine of, back to our numbers, 66.422. There you got it, 13.7. 13.7 to the nearest 10, 13.7. By the way, we don't have to do nearest 10th, we could do nearest 100th. Just make sure that when you calculate your angles, you notice I did 66.422. If you are going to be asked to give an answer to like the nearest 100th, then make sure you have your angles out to 3 or 4 places, okay? You always want to go farther than the amount you're going to be required. So if I was going to go to the nearest 100th, I'd want to go at least to 66.422. But in any event, I think the book on this particular problem wanted us to do the nearest 10th. So let's just do 13.7. 13.7 is our answer for little b, okay? So let's review. Have we found everything we were asked to find? We were asked to solve this triangle. Well, yeah, I think we have. So to be clear, we just found that this was 23.6 right here. Ay, ay, ay. Very hard to write with this thing. 23.6 for that angle. and then we just found a little b to equal 13.7. So we've got all three sides and we have all three angles. The triangle is solved. Okay, triangle is solved. That was example number 5. Maybe one more. Let's see if we can do example number 6. Example number 6 is a word problem. We have a snowboarding fanatic that wants to go down a hill at breakneck speeds, risking their life. And let's say that this hill is 3,500 feet. It's actually a small mountain. It's pretty high. 3,500 feet above the ending point, wherever the snowboarder is going to end their run. The starting point is 3,500 feet above that point. So let's make ourselves a little diagram. Here we go. We've got a hill which is 3,500 feet, okay, feet. And the snowboarder is going to run down this hill. By the way, this should be 90. And the hill is at an angle of 18 degrees, okay, 18 degrees. So the question is, how far does the snowboarder get to slide down this hill? How many feet do they get to enjoy careening down this mountain, okay? So here's our little snowboarder. See if we can draw him in here. And he's like, yay, trying to keep his balance, and he's got to travel down this hill. And the question is, how far? From start to finish, how far? And let's just call this R for the length of the run, okay? R for the length of the run. How big is R? Well, again, fairly simple problem. You look at this triangle that we've drawn here and you say, well, we have 18 degrees. We're going to use some trig. What sides are 3,500 and R relative to the 18-degree angle? Well, 3,500 is where? 3,500 is directly where? Opposite. It's directly opposite our 18 degrees. And R is what? What is R? So this is opposite. What is R? Is it the adjacent side? No, it is the hypotenuse. It's opposite the 90. So this is the hypotenuse. So which trig function is opposite over hypotenuse? Have you memorized them yet? SOHCAHTOA. Sine equals opposite over hypotenuse. So here we go. Sine. I keep switching colors. Sine of 18 degrees is equal to opposite 3,500 divided by hypotenuse. Opposite over hypotenuse. 3,500 divided by R. Oh boy, how are we going to solve this guy for R? What do you think? Well, have you ever heard of cross multiplication? This is very similar to that. This is over 1, isn't it? So if you were to cross multiply, you would get R times sine of 18 equals 3,500 times 1. Then you would divide both sides by sine of 18, and you would leave R sitting by itself. I don't usually think like that. I don't know. Maybe I've got a weird brain, but I think like this. I think move R up here and move sine down here. Okay, that's the way I think. But it really is like cross multiplication. So let me do it slowly. We're going to go R, and I will keep blue now so you differentiate it from that one. R times sine of 18 is equal to 1 times 3,500, which is just 3,500. Okay? Now divide both sides by sine of 18. So the next step is divide by sine of 18. So we're going to do this. We're going to go like this. We're going to do sine of 18 right here. And we're going to be left with r equal, okay? R equal what? R is equal to 3,500 divided by sine of 18. Okay, 3,500 divided by sine of 18. And by the way, that's 3,500 what? Feet. And sine of 18 is just a ratio. It's just a number. It's not, there's no units on it. So our answer will come up in feet. Let's calculate this now. Back to our scientific calculator. We want 3,500. Here we go. 3,500 divide by, and I'm not very familiar with how to use this guy yet, so give me a chance here. Say divide by. Okay, it does it this way. That's cool. So we're going to do sine of 18. Sine, and then we stick in our 18 degrees. 18 right here. 3,500 divided by sine of 18. And what is the answer? 11,326.2 to the nearest foot, or nearest tenth of a foot. I think they're going to want it just to the nearest foot. So 11,326 feet. Generally speaking, if you're talking about running down a mountain on the snow, you're not going to be worried about a tenth of a foot, are you? So this is going to be 11,326 feet. 11,326. Oh, if I could only get the silly thing to write. Let me move the whole thing. I don't know why it doesn't want to write very well. I'm using a touchscreen laptop, and it's not like a graphics tablet, which would be so much better. So 11,326 feet. Well, there you have it. That's your answer. And I think that's probably good enough for this particular lecture. We are simply learning how to use sine, cosine, tangent. And I think I've given you enough examples that you should be able to solve pretty much anything that you encounter. This problem here is probably the trickiest in terms of algebra, but how tricky is cross multiplication? Haven't you done that a zillion times? I think you know how. So this should not really be hard at all. I hope that this will be sufficient for you to do your assignment and do it well. Remember, solving a right triangle means finding all angles and all sides. So follow instructions carefully. If you're told to give to the nearest tenth, give it to the nearest tenth. 100th, give it to 100th, etc. All right, well, best wishes to you guys. Let me see if I can get us back to a screen here. So I can say farewell. Right, here we are. Okay, so I hope that this lecture was enjoyable for you. I like trig myself. It's a lot of fun, and it's used heavily in science, especially in physics, engineering. Trigonometry is used extensively, so learn it well. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And by the way, one last little short repetitive exposure. Tangent is actually sine divided by cosine. That's your first trigonometric identity. Tangent is sine over cosine. Another interesting fact, sine squared plus cosine squared always equals 1. Sine squared plus cosine squared always equals 1. Okay? You don't need to know that right now, but hopefully it'll help you remember it at a later date. Blessings to you all. Work hard on your homework. I'll probably make it due on Sunday since I'm late to put this out, but you should have enough time to get it done tomorrow, but we're going to let you turn it in on Sunday, okay? So have a great weekend. By the way, church on Sabbath, we are organizing. Pastor Archer is going to speak. We have a good program planned for you. I believe we're going to have some special music from some of your classmates, which is going to be cool. So we will see you at 10:55 for church, Sabbath morning, 10:55 on the Zoom link that I sent out. You should have all gotten the Zoom link. You can watch this on your phone if you've got good cell phone tower reception there, or you can do it on a laptop or a desktop. Just make sure you've downloaded the Zoom app so that you'll be good to go. All right, have a great weekend, and we will talk next time. Okay. By the way, we are at the end of the chapter. So what does that mean? Test. Yes, you got it. There's a test coming. So prepare yourselves. Get ready for that test, okay? Do your best. Thank you.